My name is Munagala Ramanath, Ram for short. I'm a software engineer at DataTorrent. And today I'll be talking to you about how to build your first application for Apache Apex. It'll be almost entirely a hands-on session. So to begin with, just a couple of sentences of introduction about what Apex is, because sometimes we get that question. Apex is a streaming analytics platform. It's built on Hadoop and Yarn, and traditionally Hadoop and Yarn have been used for data at rest, sometimes called batch, where you wait for all of your data to land in some place, like a file system or a database or a data store of some sort. Excuse me. And then you run a batch job against it. A batch job is distinguished by the fact that the data stream has a beginning and an end. There's a finite amount of data. A streaming application, on the other hand, deals with streaming data, and streaming data has no beginning and no end. So that's the distinction. And Apache Apex is designed from the ground up to deal with streaming data. And batch can be treated as a special case of streaming, so it can also deal with batch data. But streaming is where it really shines, because you can get very, very low latencies that are often not possible with many other platforms that are out there. It's all written in Java, and applications for it are also developed in Java. Okay, so that's a high-level overview of what Apex is. So for today's session, we'll be looking at the following items. First, a few concepts that are involved in Apex, in designing and building Apex applications, and then a brief description of what today's applications is going to look like, and then a hands-on demonstration of how to clone the Apex source repositories and how to build them. Since Apex is all open source, the full source is available, and it can be a great learning tool. Then we'll do a hands-on demonstration of creating a new application, and finally running the application, followed by some code walkthroughs and questions. Okay, so let's move on. The main concepts involved in Apex applications are operators, streams, and DAGs. So operators, you can think of them as traditional standalone Java programs. And an Apex streaming application is built by combining a number of such operators to form a distributed application. So a single operator does some well-defined task. It reads input that's coming to it from the stream, processes it in some way, and then passes it on to the next operator downstream. So these operators are linked together via input and output ports, and the linking is acyclic, meaning you can't have a cycle in the topology. So that's why the whole topology of the application is called a directed acyclic graph, sometimes abbreviated as just a DAG. An operator simply implements the operator interface. The interface has a few functions in it, defined as abstract methods. There's a base operator class that provides just empty implementations of all the required methods. So it's a convenient class that you can extend and override the methods that are meaningful in your situation. The ports themselves similarly have default input port and default output port classes, which you can use directly or extend based on your needs. And then the application itself is created by a Java class that implements the streaming application interface. That interface has only a single method called populate_dag. And within that method, what you'll typically do is you'll instantiate the operators that you need by just using the new operator in Java. And then you'll wire them together by creating streams that connect the output port of one operator with the input port of the next operator. Once these operators are created and the DAG is defined, the application can then be launched and it will start to process data. The operators themselves process data within what we call streaming windows, and these are time-based. The width of a streaming window is user-definable, customizable in other words, and by default it's half a second. Now I should emphasize that the streaming window doesn't imply any added latency. In other words, if a tuple comes in, you don't need to wait for the streaming window to end in order to do something with it. So some other platforms out there have some micro-batch based mechanisms that introduce these extra latencies. Apache Apex does not. So when a record comes in, your operator can process it and immediately send it out on the output port. The streaming windows are merely mechanisms for the platform to do some bookkeeping. And there are callback functions within the operator called begin window and end window that you can define if you want to, but you're not required to. Okay, so here's the sorted word count application. It has 5 operators. The first is the line reader, which is monitoring an input directory. And if a text file is dropped in there, it will read that file line by line and then output the lines on its output port. From the output port, the line will be sent to the input port of the word reader, which is the next downstream operator. It will read each line coming in on its input port, and it will split it into words using a regular expression. The regular expression itself is also a configuration option that you can define. And the words, as they go out, will reach the next operator, which is window word count. And that operator will compute and emit word frequencies for all the words that are processed in the current streaming window. So it maintains this hash map, initializes it to empty at the beginning of each window, creates these word frequencies for all the tuples coming in during that window, and then at the end window it will spit it out, the entire hash map, on its output port. That hash map then reaches file word count. File word count then accumulates all the word counts for the current file, and when the end of file is reached, it will emit the overall word frequency map on its output port. The final operator, word count writer, knows about output files, and it will take this hash map and write it out as pairs to an output file in the output directory. Okay, so here's the DAG. It shows you the line reader operator connected via a stream named lines to the word reader, which is connected by a stream called words to the window word count operator, which again is connected by a stream called window word counts to the file word count operator, and which finally emits its data in a stream called file word counts that reaches the final operator called WC writer. Notice that we have an additional stream that directly connects the line reader to file word count. Recall that I said file word count will wait for an end of file indication. This is how it gets the end of file indication. It comes through this control tuple when the line reader recognizes that it's reached the end of file. All right, so here's a list of resources that are related to Apache Apex. Okay, looks like we have a couple of questions. There's one that says, what do you mean by Windows word count? Well, by Windows word count, what I mean is a window, recall that we said that it's 1/2 second, 500 milliseconds. So if the word hello occurred twice, and if the word cat appeared 10 times, then those two pairs, hellos with a count of 2 and cat with a count of 10, is the word count for that temporal window, for that 1/2 second window. So the next question is, does Apex work on Windows? And the answer is yes. Apex will work on any platform on which Hadoop runs. So if you can get Hadoop to work on a platform, Apex will run on it. So the main Apex website is apex.apache.org. There's various forums you can subscribe to, some useful downloads. There's a sandbox, for example, with Hadoop and all the other dependencies pre-installed. That's useful for experimentation. There's some Twitter groups to follow. Lots of interesting stuff here. We're also hiring DataTorrent for a number of different roles. So if you feel that you're a good Java programmer and you're interested in joining the big data movement, give us a call and send us your resume. And finally, we have a big data conference around Apache Apex. We just finished one in Pune, India last month, and we have an analog that's due to start in San Jose on April 4th. So we would appreciate it if you could come visit us at that conference. The web page for registering for that conference is shown here, apexbigdata.com, apexbigdata.com/mountainview.html. You can register there, and we hope to see you there. All right, so that ends the slides portion. I'm going to now switch to the hands-on portion. So there's been a question about getting access to these slides. The entire webinar is being recorded, and you'll be able to you'll receive a link to the recording in due course of time, as well as the slides. Okay, so it looks like we have another question. Okay, this question says, how is Apache Apex better than Hadoop from a developer's perspective? Now Apache Hadoop is actually a lower layer for Apex. So Apex actually uses Hadoop. So it's not to say that those two are competitors. They're not. And now, having said that, typically Hadoop has been used as a MapReduce platform for batch processing, and it's fine for that. But you cannot deal with streaming data using MapReduce on Hadoop. So if you need to handle streaming data with low latencies, Apex is the way to go. Okay, so I'm going to hold off on answering questions until a little bit later in order to make sure that we have time to complete the hands-on portion. So over here, I have a virtual machine running Ubuntu Linux, and so on this virtual machine, I've got Apache Hadoop already installed, and once everything is running, you should be able to run this command called JPS, and it should show you a bunch of these Hadoop daemons running: secondary name node, data node, name node, resource manager, and node manager. If these are not running, then you'll have to find out why and make sure that they are running before proceeding any further. Okay, so that's one prerequisite. A couple of others are, of course, that you need to have Java. So you can check that by running java-version. And you can see it prints out the version of Java, 180. Now, it's not enough just to have the Java runtime. You also need to have the JDK. And one way of checking that is to run Java C-version, which is the Java compiler. And here again, it prints 180. A second requirement for today's hands-on session is the version control system called Git. And you can run git --version to see if that's installed. Finally, you also need the Maven build system, and you can check that by running mvn --version. And here you can see it prints Maven version 339. So with all of that, you're ready to get started. Once Hadoop is running, you can also connect to it, connect to the web console for a couple of those daemons. One is the name node, and to get to that, you go to localhost : port number 50,070 by default. So if you go there to port 50,070, you'll see a page like this that shows you a lot of information about the version of Hadoop and when it was started, when it was compiled, and all the rest of it. Now, an important point is to verify that it's showing safe mode is off. So if there's something wrong with your installation of Hadoop, it might sometimes get stuck in the safe mode is on status, and in that situation, HDFS is not fully operational. So you'll have to figure out why safe mode is on and find a way to get off of it before proceeding further. Okay, so this is the name node for HDFS. You can also connect to the Yarn console by going to port number 8088, localhost : 8088. And if you go there, you'll see a page that looks like this. Notice that in the lower part of the display, it shows you an application ID, the name, and the type as Apache Apex. And then towards the right, it shows you the state as killed. This is because I did a dry run just to make sure that the application works before the seminar this morning. So that's why it's showing you that application as having been run a little earlier today. Somebody wants to know which VM image is being used. It really doesn't matter, but in this case, I'm running a VirtualBox virtual machine. VirtualBox is a free download from the Oracle website. Okay, so let's go over here, and you can run some HDFS commands. In our case, the application will be monitoring an input directory on HDFS, and it will write its output to a directory also on HDFS. So I just want to show you how to look at those directories. So you type the command HDFS dfs-ls, and then you list the path on HDFS. So in this case, it's temp/test/input dir. Okay, so if we do this, it will show the contents of that input directory. That's the directory that our application is configured to monitor. And you can see there's nothing there. The directory is empty. I'll do the same thing with the output directory. And there we have it. There's nothing there either. All right, so for today's work, excuse me just a moment. Okay, so for today's work, what I'm going to do is create a whole new directory called work and step into it. Okay, so it's a new directory that has nothing there. Okay, so let me switch over to a different tab. CD work. Hello? I'm busy right now. Okay, sorry about that. Okay, so in this directory, what we'll do is we'll check out the source repositories and build them. So if I look at the URLs for the source repositories are rather long, so I've just created local shell variables to hold them. So $A, for example, has the URL for Apex core. Okay, so I'm going to check out that repository using git clone $A. So they're all on GitHub, github.com/Apache/Apache core. And notice now we have a directory called Apex core. That's where the source code has been checked out. So I'm going to do the same thing with Apex Mulhar. So Apex core is the core platform, and Apex Mulhar is the library of operators that are pre-built and ready to go. So a typical need in these streaming applications is that you need to connect to one or more external sources like databases or message buses and things like that. So each of those external systems has its own quirks. So we've built a rather large library of connectors. These are operators that you can use directly from Mulhar to connect to these external sources to ingest data. Similarly, on the output side, if you need to write the results out to either HDFS or a database or Kafka or things like that, connectors are readily available. Okay, so Mulhar is the library of operators. I'm going to check that out as well using the same method, git clone $B, which is my URL for the Mulhar repository. Okay, so while that's going on, let me see if I can answer a couple of questions. Okay, so there's a question. Okay, so there's a question about MVN. MVN is downloadable from the Apache website. Just search for Maven on Google and you'll be able to download it. There's also a question whether, if you use Eclipse, whether it has everything in it. Eclipse will naturally, if you have Java support, will naturally have Java. But the other prerequisites like Git and Maven, you'll have to explicitly download yourself. So another question that's come up is what Hadoop distribution is being run? And the answer is, in this particular demonstration, I'm not running a distribution. I downloaded Hadoop 272 directly from the Apache Hadoop website and installed it using their instructions over there. So it's not a distribution. It's just Hadoop downloaded and installed as per the instructions on their website. Another question says, do we have any VMware images or Docker images? We don't have VMware images as far as I know, but if you go to the DataTorrent website, you can download a sandbox, which is a VirtualBox image, and that's usable. You'll need to download and install VirtualBox from Oracle, and it's a free download. Okay, so There's another question that says, can you do visualization? The answer is yes. Apex can do visualization, but that's not part of the open source release. DataTorrent does have a product called RTS, which has a very nice web console and support for visualization. You can download a evaluation copy from the DataTorrent website. Okay, so that takes care of some of the questions. Let's look at what we have here. We have Apex Malhar has also been cloned. And there we have the two directories. There's one more directory, and that has a number of different examples. So I'm going to clone that repository as well. I have the URL for that repository in my variable C, github.com/datatorrent/examples. Let me clone that as well. So git clone $C. And this should be really fast because there's not a lot of files there compared to the others. Okay, so that's done as well. And we have the three directories here. Okay, so let's now build them. I'm going to step into Apex Core. Oh, don't need the ... just Apex Core. And here's the contents of Apex Core. Now here you'll notice there's a README file that has some information about the repository and the pom.xml. So this is the file that controls how the building happens by Maven. Okay, so the typical way to build these sorts of Maven projects is to do maven clean install -d skip test. So since that's a command that's very commonly typed, I've created an alias for it, which I call just mvn go. So I'm showing you the alias here. It's just mvn clean install -d skip test. So the clean gets rid of any artifacts from a previous older build. The install will install the artifacts into your local Maven repository. So the local Maven repository is typically in a directory called .m2. So if I do a -ls-l ~/.m2, you'll see there's a subdirectory called repository, and that's where Maven places all the artifacts. So the installation is done locally to your home directory, so you don't really need root permissions or super user permissions to do the install. It's not installing anything to the system directories. And finally, the skip tests will skip running the unit tests because we don't really need to run the unit tests for this webinar, and it also takes a fair bit of time, several minutes, to run those tests. Okay, so let's run that command, mvn go, through the alias, and it will go ahead and build. So this takes about a minute and a half or so. So we'll let it do its thing. And while that's going on, let me go over here and see if there's additional questions. So there's one question that says Apache Spark works with streaming data, so how is this different? Spark has this notion of a microbatch. So when input records come in, it has to wait for an entire batch to accumulate, a microbatch, before it starts processing. So this imposes inherent latencies, very substantial latencies. So Apache Apex does not have that limitation, and it can go as fast as the data can be fed in. Okay, now one of the things I wanted to show you is the Java docs. So for the two repositories, Apex Core and Apex Mulhar, the Java docs for all the classes are available here. The URL is ci.apache.org/project/apexcore/apexcore Java doc release 3.5. And it has the traditional look of a Java docs page with the packages on the top left, all the classes on the left panel, and individual pages displayed in the middle. Similarly, you can go to the Mulhar part. It has a very similar URL, ci.apache.org projects Apex Mulhar Java doc release -3.7. Finally, there's a documentation page that we maintain at DataTorrent that has a lot of external documentation about running Apex, and that's at docs.datatorrent.com. So you can go to this beginner's guide over there. The left panel is the navigation panel. The beginner's guide is a good place to get started building Apex applications. It has a fairly comprehensive view of the entire platform and its capabilities. And many parts of today's tutorial are also discussed in the beginner's guide. Okay, so let's go back here and see what happened. So look, the build is a success. It prints out build success. So Apex Core has been built. We're going to do the same thing to Apex Mulhar. So I'm going to run the exact same command, mvn go, which is my alias for mvn clean install -d skip tests. So this one can take about 3 to 4 minutes because it has many more files that it needs to compile. So while that is going on, let's go over to a different tab. Go into the work directory where we have all our stuff. And I'm going to show you this maven command that we will use to create a brand new maven project for today's application. I have it in my home directory called new project, but it's a very small file, and it looks like this. Maven mvn-b, and then a list of options to generate the new project. Now you don't have to remember all of this. This is actually in the source repository for Apex Core that we just cloned. So let's just take a look at it. Let's go into Apex Core. And if we go into Apex app archetype, you'll see there's a README file there. And that README file has the exact maven command that you need to run. So this is the maven command that is in the file that I just showed you, where I've just split it into multiple files. I'm sorry, split it across multiple lines for better readability. And I've also added a -B option at the very beginning, right after MVN. The -B stands for batch. And what that does is avoids interactive question where you have to type yes. So it's more convenient when running as a script. So just to recap, here's the file called new project where I have that maven command. It's a single command split across multiple lines. All right, so I'm going to move back up and let's see if what's happened with Malhar. Looks like it's continuing to build. It should be close to the end by now. So let's wait for that to finish. So there's one more thing I can show you, and that is the Apex, Apache Apex web page. It's at apex.apache.org, and this is what it looks like. You can go into the community page for the mailing lists and subscribe to mailing lists, where if you run into issues, you can ask questions. And usually there's pretty quick and pretty timely responses on the mailing list to any problems users might be having. There's also guidelines on how to contribute if you're interested in doing that. There's this documentation page, which has a lot of information, pointers to slide decks. Here's a link to that beginner's guide I was telling you about. And there's additional documents for Core and Malhar, and many different presentations and blogs that have been done over time. At the end down here, there's a troubleshooting guide, and that's also very handy if you run into problems, because a lot of different issues that people run into have been documented along with their solutions. So that's a good place to look at if you run into issues. Okay, so we have a question that says, how is Apex different from Storm? Storm requires you to do a lot yourself as the application developer. Apex automatically handles a lot of things, like, for example, fault tolerance. You, as the application builder, don't have to do anything. Fault tolerance is built in to the Apex platform. Additionally, automatic scaling is built into the platform. So you can configure it so that if a particular operator is becoming a bottleneck, the platform will replicate that operator into multiple copies of itself. We call that partitioning. So that one operator can then split into, say, a dozen copies, and they all share the processing load of the input stream. So that can give you close to linear improvement in performance. So those are some of the differences with Storm. It's generally a much friendlier environment to program, much easier to develop Apex applications. Another question says, how recent is Apex? It was donated to the Apache Software Foundation, I believe about a year ago, and it was in development for a couple of years before that. There are already multiple deployments in production. Some large customers are already using it, GE is using it in their Predix platform. Capital One is using it. So there are many commercial customers who are already using it in production. Okay, so let's go back here. Here's the build success. So Malhar is also successfully built. So let's go back and we'll now run that maven command to create a new maven project. Okay, so I'll run bash on the file called new project that I just showed you to create my new project. It should run and create a directory called my Apex app. Here's the directory called my Apex app. So I step into that. Oops, my Apex app. And here's my new project. It has this pom.xml, which, as I mentioned before, guides the Maven build of your project. So what I'll do now is we could actually build this because there's a ready to go application here with two operators, a random number generator, which generates random numbers and sends it to a console output operator. But rather than doing that, we'll go ahead and add the files for our sorted word count and then build it. So what I'm going to do is step into source and then to main and then to Java and then to com example my Apex app. This is the directory that holds the source files. So there's a couple of source files, as I mentioned already here. So what we're going to do is the source files for our sorted word count application are present in this examples tutorial that we just cloned. So if I go into examples and then go into tutorials, top N words, webinar, you'll see here's a whole bunch of Java files. So these are the Java files that we're going to copy over into our new application. Okay, so I'm going to copy that directory path, go over to the other tab, and then do a cp command where I copy all the Java files to that location. Okay, so here they are. All the files have been copied over. There's one other file that's a configuration file that we need to copy, and that goes into the resources directory, under which there's a meta-inf. And if you look there, there's a file called properties.xml. What we're going to do is copy the XML file from that webinar directory over here. And if I do the ls command, you'll see that this new file, properties-sortedwordcount.xml, has been copied over here. It has some configuration values. So if we take a quick look at it in VI, you can see that it's an XML file with name value pairs. And here you can see that the line reader operator's monitored input directory is specified here as temp test input dir. If you recall, a few minutes earlier, we were running HDFS commands to list the contents of that input directory. And here again is the output directory in the configuration file. So that's all configurable. Okay, now that we've copied over the necessary files, I'm going to move over to the top level of my new project, and it's now ready to build. So I could run the same command as before, the maven command to build, but in this case we don't need to install the artifacts into our repository. We just need to create packages. So I have a different alias called mvn package, and you can see it's very similar to the previous one, but it says mvn clean package instead of install, and then -d skip test. So I'm going to run this command, and you'll see that it will create a directory called target. Right now there is no directory called target. When we run that command, it will create a directory called target, and under there create a whole bunch of files, one of which will have the .apa extension. The APA stands for Application Package Archive. It's also in the jar file format. Okay, let's do that. mvn package. Should go pretty quick. Okay, build success. So it's successfully built our new project. If I do an ls, there's that target directory that's been newly created. Now if I do an ls on the target directory, you'll see that it's created this APA file. Okay, so that's the file that we'll be launching. Now, to launch it, we need a script from Apex core. So if I run the find command on Apex core and give it the name just Apex, it will find it. So under Apex core, which we just built in a different directory, you'll see there's this script subdirectory under which there's this file called Apex. So that's a command line tool for launching applications. So we're going to go ahead and launch that. Okay, so here it is. You can type help to get some help on the various commands it has. You can type list apps to show the list of applications that it knows about. And as I said before, I ran this application earlier this morning and then killed it, so it's showing me a record of that application saying the state is killed. It's no longer running. Okay, so the way we launch is we say launch and we give it the path. So it's target / there's only one APA file, so we can use wildcards star.apa, and that should launch the application. When it successfully launches, it will print out the application ID. Okay, so here it actually gives me a choice because there's two applications there. One is the random number application that it came with by default, and the other is the sorted word count application that we just added to it. So we need to pick one. So in this case, I'll pick 2. Okay, so it should then show me the application ID, and there it does. This long string that says application underscore whatever underscore and a number, that's the application ID. So the application is now running, and if I say list apps, it should show me both, and indeed it does. So it shows the state as accepted. So if I now go back here to the Yarn console and refresh the page, I should see that application as well. So I just refreshed it, waiting for the results to display. Okay, here it is. The application with _002, it shows you that the state is running. So our application is running. Okay, so now what we need to do is go back to this tab and we need to give it an input file. So under share, I have this text file called prideandprejudice.txt. This is a copy of the Jane Austen's novel, a fairly large text file. So I'm going to copy that over to the HDFS directory that we saw before. Here's the earlier command where we did the HDFS, DFS, LS on this directory. So what I'm going to do is, instead of ls, I'm going to run the put command and give it the path to the Pride and Prejudice text file as the source. And for the destination, it's temp test input dir. Okay. So that will copy it to the input directory, and the application will start processing it. So let's do the ls command again to see that the file is actually present in the input directory. And indeed it is. You can see it's about a megabyte, about 3/4 of a megabyte. All right, so let's do the ls on the output directory to see if it's created anything in the output directory. Okay, and it has. And you can see the timestamp is right now. However, notice that the output file is a lot smaller. And that makes sense because the output has the word frequencies, words and the number of times each word occurred. So let's look at what's in the output that's just been produced. To do that, I'm going to use cat output dir slash. So it creates the file with the same name in the output directory, prideandprejudice.txt. So I'm going to cat that file, but it's got a lot of lines, one for each word. So I'm going to pipe the result to head so we don't flood the console with data. So we'll see just the most frequent words, and there it is. The word the occurred 4,218 times, and then the rest of the words that you would expect to be most common in English text, the various prepositions and conjunctions and pronouns such as and her and I and a and so forth, the articles, those show up at the very top. So our application has successfully processed the input file and produced the sorted word frequencies. Okay. Now let me just spend a brief moment going to the source directory here under work, source, my Apex app, source, main, Java, com, example, my Apex app. And let's look at application word count. This is our main application file. Notice that the application file is actually pretty short. There's not a lot of code here. You first need the various import statements in Java, and then there's this annotation that provides the name for the application. In this case, we call it sorted word count. And then there's this class called application word count that implements the streaming application interface, as I mentioned first during my slide presentation. So within that, we have this populate DAG method. And in that method, that's the only method we need to implement. There's two groups of statements. The first group creates the operators, the 5 operators we talked about: line reader, word reader, window word count, file word count, WC writer. So here we create them with the new operator and pass them into the add operator method for the incoming DAG. That method will do some internal bookkeeping and then return that same object. So we save it in local variables here. The second block of code simply creates the streams from the output ports of operators to the downstream input ports, one at a time. So here's the streams. The first argument is just the name of the stream. The second argument is the output port from line reader, in this case, line reader.output, and that gets connected to the word reader's input port. So here's the word reader operator, and we connect it to the word reader's input port. And the same for all the rest. Okay, so hopefully you've gotten a sense of what it is like to build Apex applications today. I encourage everybody to go to the website and give it a shot. I think you'll enjoy the experience. Let me see. It looks like there's a couple of questions here. There's one that says, do you have examples like the Java one shown here, but built with Python or Node.js? We don't yet have a Python API, but that's in the works. There's people actively working on it, and in the next few weeks, that'll hopefully be available. Node.js, as far as I know, there is no support for JavaScript-based building of Apex applications. Another question says, does the platform provide timing info and other stats on the Apex application we run? Yes, various statistics are available, but they're not part of the open source release. DataTorrent has a RTS product, which has a nice browser-based console that shows all of those statistics. Another question says, can it be used for sentiment analysis, or should it be part of some deep learning experience? These operators that form part of your DAG, one of those operators could be a machine learning operator. So Apex does not out of the box provide a machine learning operator, but you can certainly create one and hook it into your DAG for doing machine learning. Okay, so it looks like we're well over the time limit. Will it help to move configuration of the DAG? Will the video be available? I assume it means for further training. Yes, the video and the slides, the whole webinar has been recorded, and you'll get a link to it in the days ahead. So yeah, you can certainly review the video because it's all been recorded. You'll be getting a link. All right, thank you everybody for listening, and all the best with Apex. Make sure you join the mailing list and ask any questions you have over there. You'll find the environment very welcoming, and the answers will usually be very timely. Thank you, and goodbye.